So if you're watching this video, this is not a lesson. This is just I'm going to be recording the entire class of us going over problems that were assigned from yesterday and other problems that we're going to be working on today. For those of us in the class, if at some point you're done with this set of problems, which again is on page 9 and 10, not 6 and 7, and you're satisfied that you understand how to do all of them, there's an additional set of problems which start on page 23 to 25. It's outlined in your handout at the end of the lesson. They're called supplemental problems. So you can always go to page 23, 24, and 25 and work on the problems there, except for the ones that say prove, because we haven't formally studied proofs. So there's an entirely different way of thinking about what we're doing here. What we are doing is algebra. It deals mainly with factoring and rational expressions, which you learned about, well, in grade 10, but rational expressions more in grade 11. The only thing that's different is instead of having rational expressions like x squared minus x minus 1, you might over x plus 2, you might have a rational expression like sine squared of x minus sine squared, or minus sine of x minus 1 over sine x plus 2. Or whatever the case is, you're going to have trigonometric components to things. In order to simplify trigonometric expressions, you have all of these tools. I would say they're not necessarily listed in the order you're always going to follow, but the one at the top of the list is the one that's most frequently helpful. Okay. I don't always change everything to sines and cosines, but when I do, it almost always helps. Not all the time, but most of the time. If you see things that are familiar, I said this morning in Sabre Support, it's like running into an old friend. Mr. Flynn was in Hawaii over the break, and he ran into a teacher that used to teach here, a good friend of mine. He ran into her. He hadn't seen her in maybe 15, 20 years. And he recognized her just like that. Well, you have to recognize things like sine squared of x plus cos squared of x. You have to go, oh, that's 1. Now, I'm not saying you have to memorize your formula sheet, but you want to keep your eyes peeled for those things. Okay? Additionally, if you see things that can be factored, then you would want to try to factor things. And we looked, I believe, at least one example this morning where you could solve it by factoring, or you could have solved it even though we didn't do it that way by replacing everything with sines and cosines. It's just a different path to get to the answer. Always, this overrides everything else. If you have fractions that are being added or subtracted, for example, now I can't find it. There we go. If you have fractions that are being added or subtracted, if you were to write everything here in terms of sine and cosine, this minus in between would mean you would have fractional things that are being added or subtracted. You have to bring them together with a common denominator. And finally, ultimately, if you've done everything you can and things are just not going your way, just reevaluate. Just go back to the beginning and say, is there something that I could have done differently? So let's open this up now. This is on, again, page 9 and 10. That should say, any questions? Go ahead, Jesse. 4D. 4D? Okay. So the other thing I mentioned in Sabre Support, and you were here this morning for that, but I'll mention to everybody, there's a real huge difference mathematically between something like 4D, and I'm going to get to your question in a second, Jesse, but I want to highlight something. There's a huge difference between mathematically what's going on in 4D and what's going on in 4F. And it's that in D, everything is being multiplied together, and in F, it's not. There's an addition sign separating things. I'm going to come back to that to make a broader point in a second. Let's start with the idea that I can write everything in terms of sines and cosines. So I should know by now that secant of a rotation angle, or secant of a variable, I guess we can just say, is the reciprocal of cosine. Sine squared, again, I made this point yesterday, and I'm going to make it again now, and I made it again at least 3 times this morning in Sabre Support. Look where I wrote that sine squared of t. Look how I wrote it. I did not write it here. I wrote it here because it's a numerator. And if I want to, I can include the denominator of 1. That's important. And then cosecant of t is the reciprocal of sine of t. And I'm going to just for this one, I might do it for other ones, I'm going to rewrite this as 1 over cos t times sine t times sine t times 1 over sine t. And all I've done here is I'm just indicating to you, everybody, that sine squared of t means this. That's all I'm saying, okay? And because it means that, I can cancel a sine t with a sine t. For those of you that were here this morning in Sabre Support, you know the answer to this question. Why am I allowed to cancel that? Janessa? Because I'm multiplying things here. Everything is multiplied. That's the most important thing, I think, in rational expressions that I try to focus on in Math 20-1 is you're allowed to cancel if you cancel something that's a factor with something that's a factor. And the only things that are ever factors are things that are multiplied by everything else. Okay? It's fundamental. So now, scan across the top of this entire fraction, what do we have? We have a sine of t. Scan across the bottom, all we have is a cosine of t, and you should immediately recognize that as tangent of t. Okay? Now I know, and we're good with that now? I know that you didn't ask about f, but let's talk about f here. F, if I were to replace everything with sines and cosines, this is what I get. Because the cotangent is cosine over sine, and then it's multiplied by another cosine. Can I, and again, we talked about this exact example, I think, this morning. Am I allowed to do this? No. Why not? Lynette? Because I'm adding. That really is going to be a lifesaver for you on exams and in your work. If you're multiplying, you can cancel. If you're adding, you can't. Now, you know, could I, if there was another sine of theta on the top of this fraction, could I cancel it with that sine theta? Yes, because in that section I'm multiplying. But this is a case where you can't cancel the signs. What you need to do instead is look at finding a common denominator. This is over 1. This is over sine. Well, I can make this over sine if I multiply the top and the bottom of this by sine of theta. So whenever you're adding things together, whenever is a bad word here in this unit, but often when you're adding things together, you want to bring them together with a common denominator. When I do that, sine times sine is sine squared. And then I have my cos times cos, which is cos squared. And I know that nobody asked about this, but when you bring fractions together with a common denominator, the common denominator stays the same. There's our old friend, sine squared of theta plus cos squared of theta, which is 1. So for f, the answer would be 1 over sine of theta, which, you know, if it were a multiple choice question, and I think this is a good multiple choice question, I would probably have cosecant of theta as the answer. And maybe secant of theta, and maybe sine of theta, and maybe cos of theta. Other questions? Go ahead.
11.
Okay, let's look at number 11. And remember, I might as well just jump ahead here. Remember that if at some point you feel you're done with following along with that first set of problems, this is the next set of problems that we're practicing today. And at the beginning of tomorrow's class, we'll spend a few more minutes going over everything again. Okay? But then tomorrow we move on. So you said 11, is that right, Ariana? Okay. So secant minus cos. There's not really a whole lot of options here. If I go down my list, I can't factor anything. There's nothing factorable here. I don't have any fractions yet to bring together. I don't recognize something. So all I'm left with is writing everything in terms of sines and cosines. And if I do that, secant is 1 over cosine. And then I have minus cosine. Again, I honestly hope you get tired of me saying this, because then that means you understand. Look at how I wrote that cosine of x for the second term. I wrote it so that I can put it over 1, lined up nice and smartly with the 1 over cos x. Now, can I cancel these? No, I can't do that because I'm not multiplying those terms together. So the only option I have here is to bring these together with a common denominator. And I mentioned this morning in Sabre support, you know, lowest common denominator, people kind of get rattled by that. The lowest common denominator, there's two ways to think of it, is simply the denominator that you're able to convert everything to. So if one of my fractions is over cos of x and the other is over 1, then I can multiply the top and the bottom of this other fraction by cos of x, and that demonstrates that that's my common denominator. The other way to look at it is your lowest common denominator. And if you had me for Math 20, this might ring a bell. Your lowest common denominator has to contain all of the factors in the original fractions, denominators. So the lowest common denominator has to contain a cosine of x, because cosine of x was a factor in a denominator. And it has to contain a 1, because 1 was a factor. Well, that means it's cosine of x. So what do I get here? I get 1 minus cos squared of x. Are you okay with that move? All right, when I put these together, I get cos of x on the bottom. I didn't write cos squared because I multiplied. My brain slipped a gear. The denominator stays the same. And then I have 1 minus cos squared here. A question for you. How many of you recognize the numerator is sine squared of x? There should be more and more of you every day that goes by that recognize that. And what we're talking about here is that most familiar of identities. Can I ask you a question? I don't know why I don't know this. Is this written this way on your formula sheet, or does it have cos squared first?
No, it has sine first.
It has sine squared first, okay. If I rearrange that for sine squared, I get 1 minus cos squared. So the top of this is going to be sine squared. And by the way, if you ever see, and we ran into this morning, if you ever saw cos squared minus 1, it would be negative sine squared. So there's lots of variations there. I end up with sine squared of x over cos of x. I'm going to look at my answers here. I don't see it, but one of the points I made this morning in Sabre support, and everybody should appreciate this, that these trigonometric expressions can take on many appearances and still be the same. And when I look at this, and I know I have a lot more experience with this, but when I look at this, I can't help but realize that there's a tan of x in there. Right? Sine x over cos x is tan of x. I don't care which one you choose. If you choose this one, this is tan of x. And now we can see that the answer is sine of x times tan of x. Alternately, if you're confident that this is the answer, that it's a correct result, alternatively, you could go to all your choices and start trying to find out which one of them you can turn into sine squared over cos. Other questions? Yeah. 6G. So let's, because it's good for practice, let's convert everything to sines and cosines, and then I'm going to come back and do it. There's a real quick shortcut to the answer, or a shorter process. But this, converting everything to sines and cosines and doing the algebra to simplify things, is good practice with rational expressions and canceling and all that stuff. So I can write 1 plus cotan squared as 1 plus cos squared over sine squared. And you know what? I get lazy in my language, and I have to be better at that. I shouldn't say 1 plus cos squared over sine squared. I really should be saying 1 plus cos squared of x over sine squared of x. And that variable has to be there. Over secant squared of x is 1 over cos squared of x. And we have this mess. Are we okay with that to that point? Okay. Now I know if you were here this morning, you're going to hear the same story that I told this morning. But I want to go back to when we were looking at using this earlier in this unit and also in the previous unit. And let's say you had a problem where you're trying to find b, and you've determined that the period is 3 pi over 4. And the question is, what's b? Okay. Well, when you rearrange this equation, b is 2 pi over the period, which means we're going to get b equals 2 pi over 3 pi over 4. And I mentioned at the time, and I'm sure it was more than once, you're taught that to simplify this, you, instead of dividing by this fraction, you multiply by the reciprocal. But I've told you, don't do that. That's a very limited rule. What you should be doing instead is multiplying the top and the bottom by whatever is necessary to get rid of this mini denominator. So what happens here is this 4 cancels with that 4. I'm left with 8 pi on the top. I'm left with 3 pi on the bottom. So the pi's cancel. I'm left with b is 8 over 3. Okay. What am I talking about? Why am I talking about this? Because that's the exact same thing we're dealing with here. I have two denominators that I would call mini denominators. Let's go yellow. I want to get rid of this and this. I don't like fractions within fractions. So how can I do that? I'm going to multiply the top and the bottom by whatever is necessary to get rid of all of those mini denominators. Well, I need to multiply the top and the bottom by sine squared of x to get rid of the sine squared of x that's highlighted. I need to multiply top and bottom by cos squared of x to get rid of the cos squared of x that's highlighted. So if I did this, I'm talking general math here, not trig, not identities. If I simply did that, what would be wrong? What am I forgetting to do here? If I wrote 1 plus the cos squared times the cos squared, what am I forgetting to do? Mariana, do you know? Right. I have to do the following. I have to multiply this by the 1 and by the cos squared over the sine squared because of that plus. Okay? It's not like it's times and I can just cancel and move on. There's more involved here. So what I'm going to get on the top will be the sine squared. I really don't even like putting these in here. I'm going to have sine squared x cos squared x times 1, which is sine squared x cos squared x. And then I'm going to have sine squared x cos squared x times cos squared over sine squared, and the sine squareds will cancel there, giving me cos to the 4 of x. This is over, on the bottom, the cos squareds cancel and I'm left with sine squared. Is the answer to this 1, by the way? It's not. Okay. Is the answer to it cotangent squared? Sine squared x? Yeah. Okay. Which is cotan squared x. Now what? And don't forget, this is the long path. There's a quicker way. Well, now we can factor a cos squared of x out of the top. And if I take cos squared of x out of the top, I have left sine squared of x plus cos squared of x. Hello, old friend, which is 1, right? Over sine squared of x. So since that's 1, we just don't need to write it, and we get cos squared of x over sine squared of x, which you could write cotangent squared. I don't know what the question is asking us. I think the question probably says rewrite everything in terms of sine and cosine. Yeah, so we're done. Now, is there another way to do it? Well, I actually don't know, because no matter how good you get at this, no matter how long you do this stuff, decades for me, I still can't see every destination just in my head. I have to actually start walking and seeing if it's going to work. But are you okay with that? Okay. So what if now we say the following, and this is a point I made this morning in Sabre Support. There are those Pythagorean identities. I want to pull them up here. The Pythagorean identities are these 3 identities that are in the center of the screen. And what makes them recognizable to me is they all contain the number 1, and they all contain squares of trigonometric ratios. And when I look at this question, I see 1 plus cotan squared. Now, we'll want to be careful here. Oh, right there, look at that. 1 plus cotan squared. I was going to say I want to be careful because it doesn't necessarily mean we're going to see 1 plus cotan squared, but we do. It's equal to cosecant squared. So if you can see that, then you can write cosecant squared of x over secant squared of x, and now put everything in terms of sine and cosine. I want to make one more point about how I wrote this, and I'm even going to exaggerate it more. The point I want to make is this line is longer. I don't ever want to write a complex fraction like that, where all of the lines are equal, because I don't know what it is that means exactly. I can multiply top and bottom of this now by cos squared of x and sine squared of x. On the top, these cancel. On the bottom, these cancel. Kablam. You're left with cos squared of x over sine squared of x, which is the answer. So what I would say to you, I guess, is that even though replacing everything with sine and cosine is almost always going to work, very often some of the other things supersede that. Like factoring sometimes works better, and sometimes using a different identity works better. Other questions?
Can you do question E?
E? The same set? All right, we have cosecant of x minus sine of x. There are no other options here other than to write everybody with sines of x and cosines of x. There's nothing to factor. I don't recognize anything. I don't have any fractions to bring together yet. But I will as soon as I put cosecant of x is 1 over sine of x. And no matter how often I do this, I always want to just double check. Is cosecant the reciprocal of sine? Yeah. Pretty sure. Are you sure? Okay. Minus sine of x again. I don't want to be so repetitive that I put everybody to sleep, but again, look where I put the sine of x. That's important. Can I cancel those two sines of x's? No, because I'm adding the things together. And if you learn one thing today, one new thing, other than just getting better, it's when can you cancel and when can you not? Which again is a Math 20 idea. I'm going to convert these, Ali, both to denominators of sine x so that I can bring them together as one fraction. And since one of these is over 1 and the other is over sine x, I can multiply the second by sine x over sine x. Oh, I'm allowed to do this, by the way, because sine x over sine x is 1. I'm not changing the value of anything. And I get 1 over sine x, pardon me, I get 1 over sine of x minus sine squared of x over sine of x. And now I can put these together because they have the same denominator. So it's going to be over sine of x, and it's 1 minus cosine squared of x, and, pardon me, 1 minus sine squared of x. I'm just kind of thinking ahead and doing too many things at once. You should recognize, well, my hope is that everybody recognizes this as cos squared of x. And I can't, now I'm mixing up Sabre support with what I've already talked about in this class. The idea here is that sine squared of x, I'm sure this has come up already in this class, plus cos squared equals 1. If I subtract sine squared of x from both sides, I get this statement. Yeah, it has come up already, but I think it was the other one we were rearranging for. So that's cos squared of x. Our answer then is cos squared of x over sine of x. That's an answer. Were we asked here again to write everything just in terms of sine and cos? Then that's what we would put. But there are going to be lots of cases where you have multiple choice questions, and that's not going to be the choice. It's not going to be a choice. You have to do something else to it. Sometimes you have to do some very sneaky stuff to get the right answer. And there's at least one in this that nobody's asked about yet that I'm sure somebody will, where we're going to have to do something really sneaky. Anyway, Ali, is that okay? Okay, good. Other questions? Yep. 14? we had a similar question. I think you might have even asked about it this morning, where that stuff at the beginning about what cannot be equal to 0 was just there because that would create undefined expressions. So sine of x can't be 0 and cos of x can't be 0 because within here somewhere you're dividing by sine of x and you're dividing by cos of x. We're asked to simplify that basically. So I made this point this morning. It might have even been the same type of question. Since everything on the top, well, two things. Since this is one fraction and everything on the top is multiplied together and everything on the bottom is multiplied together, this is crying out for you to change everything to sines and cosines because you can cancel whenever you're multiplying. So when I rewrite this, I write sine x over cos x for the tan x times the cos x on the top. I see immediately that I'm going to be able to cancel a cos x on the top. On the bottom, I have a 3, and then I have secant of x, which is 1 over cos x. Now, notice where the 3 is. It's not 1 over 3 cos x. The 3 is being multiplied by secant of x, which is being multiplied by cotan of x. So it's 3 times secant, and secant is 1 over cos, times cotangent, which is cos over sine. Oh, we're catching some lucky breaks here, aren't we? Just want to double check because I'm talking, writing, and thinking at the same time. But I think that looks fine. Okay. We're catching a lucky break on the top because I can cancel those because I'm multiplying in between them. We're catching a lucky break here because I'm multiplying on the bottom so I can cancel those. So now let's just rewrite this a little bit. We have sine of x over 3 over cos of x. Pardon me. The things that survive on the bottom are the 3 over the sine of x. So now I have a complex fraction. I'm going to multiply the top and the bottom by sine of x to get rid of that denominator in the denominator. And I'm going to be left with, in the numerator of this entire fraction, I'm going to be left with sine squared of x. And then on the bottom, I have 3. And you should recognize that this is the same as that. Dividing by 3 is the same as multiplying by 1/3. So I have 1/3 sine squared of x. Other questions?